All right, here we go. Now, this might sound like a really strange question, but are you watering yourself like a corn plant? Stick with me here, because today we're going to explore what the super precise science of watering corn can teach us about our own hydration. And trust me, the answer is probably not what you think. So let's start with a question we have all asked ourselves at some point. How much water should you actually drink a day? I mean, it feels like a basic health fact we should all know, right? The internet is just flooded with answers, but there's one number, one specific rule that you hear over and over again. Yep, you know exactly what I'm talking about. The 8x8 rule. 8 8-ounce glasses of water every single day. It's so simple, right? It's easy to remember, and for decades, it's been treated as the absolute gold standard of hydration advice. But here's the big question. Is it actually right? Okay, before we get to the bottom of that, we're actually going to take a little detour. A pretty weird one, I'll admit. Because to really understand how we should hydrate, we first need to understand the science of farming. Yeah, you heard me right. Just trust me on this, it's all going to make sense. So let's ask a totally different question for a minute. How much water does a corn plant need? Now, the thing is, for farmers and agricultural scientists, this is not a guess. There's no simple 8 glasses rule for a corn plant. It's a critical, precise calculation that can make or break an entire harvest. So to figure out how much water a plant needs, you first have to know how it loses water. And it happens in 2 main ways. First, you've got evaporation right from the soil, we'll call that E. And second, there's transpiration, which is water vapor released from the plant's leaves. Let's call that T. You put those 2 together, E plus T, and you get this one big, important term, evapotranspiration, or just ET for short. This is basically the grand total of all the water that's leaving the field and going back into the atmosphere. It's the total water loss, and that's the number you have to replace. So how do they calculate that exact amount? Well, they definitely don't just guess or use a catchy rule of thumb. Scientists use a really precise formula. It's an actual equation that's, well, let's just say it's way more sophisticated than drink 8 glasses a day. And the process is actually pretty slick. It's basically a 2-step approach. First, they figure out a baseline water loss for a perfectly standardized patch of grass. Think of it as the control group. That's called reference ET. Then, and this is the key part, they multiply that baseline number by a special factor called the crop coefficient, or KC, and that gives them the final, totally customized answer for their specific crop. And this really shows you how it works. You've got your reference, that's the baseline water loss from the standard grass, which is really just affected by the weather. And then you have the actual water need for a specific crop, like corn, which is a totally customized calculation based on that reference. But get this, it gets even more complex. Because if a plant is stressed out, maybe the soil isn't great or it has a disease, its water needs change again. So the equation has to be adjusted for that too. The point is, there's no single fixed number. It is always changing. So let's dig into that special multiplier, the crop coefficient. This thing is basically the secret sauce of the whole equation. It's the key variable that makes it all work, because it accounts for one simple fact. Every plant is different. This Kc value is a super carefully determined ratio, and it's not static. It changes based on the type of crop. A tomato is not a potato, right? It changes based on the plant's age. A little seedling needs way different amounts of water than a full-grown plant. And it even changes based on the local climate. So the number for corn in a cool, wet place is going to be totally different than for corn in a hot, dry. Okay, so what on earth does all this crop science have to do with you and me? Let's bring it back home, back to that simple rule we all grew up with. I mean, if watering a humble corn plant is this complex and this variable, does it really make sense that human hydration is as simple as one fixed number for everyone? Well, according to experts at Michigan Medicine, the answer is a big fat no. That famous 8x8 rule, it just isn't backed by any real scientific evidence. Plain and simple, it's a myth. So why is it a myth? Well, for a few big reasons. First, the number itself is totally arbitrary. There's no big scientific study behind it. Second, it completely ignores all the water we get from food. Think about it, fruits, vegetables, even soups. And maybe most important of all, our bodies already have an amazing, super sophisticated hydration monitor built right in. It's called thirst. So here's the big takeaway. Just like that corn plant, you have your own personal water equation. You have your own set of coefficients, your own unique factors that determine how much water you actually need on any given day. And look, here's the side-by-side. For a crop, the factors are things like climate, soil, and its stage of growth. For us, well, it's our location. Are you in a hot climate or a high altitude? It's our activity level. Did you sit at a desk all day or run a 5K? And it's our own unique body size, metabolism, and health. These are all variables in your personal hydration equation. So how can you tell if you're getting enough water? It's time to forget counting glasses. The answer is much simpler. First and foremost, listen to your body. Thirst is your #1 guide. It's the best, most immediate signal you have. And second, a really easy one, check the color of your urine. If it's pale yellow, you're in great shape. If it's starting to get dark or has a strong smell, that's a crystal clear sign from your body that you need more fluids. You know, the problem with a single one-size-fits-all number isn't just that it's unscientific, it's that it can actually be dangerous. It creates this idea that more is always better, and when we're talking about water, that is absolutely not true. In fact, drinking way too much water too quickly can lead to a very serious condition called water intoxication, or the medical term is hyponatremia. What happens is the normal balance of electrolytes like sodium in your body gets dangerously diluted. This causes your cells, especially your brain cells, to swell up with water. And yes, it can be fatal. And this isn't just some theoretical what-if scenario. This really happens. It's a known risk for endurance athletes like marathon runners who overhydrate. It's happened to military trainees during intense exercises. And tragically, it happened to a woman named Jennifer Strange back in 2007, who died after taking part in a radio station's water drinking contest. A single, simple, wrong idea about water can have absolutely devastating consequences. So when you boil it all down, this isn't really just about water. It's about questioning those simple, one-size-fits-all rules we tend to follow without a second thought. I mean, if the science for watering a corn plant is this personalized, this dynamic, and this smart, doesn't our own health deserve at least the same level of nuance? It makes you wonder, right? What other simple rules do we follow every day that might need a second look?